In this video, we're going to introduce the idea of how to solve absolute value inequalities. Now, we're going to have to still apply the definition of absolute values in order to help us. Remember, absolute value is defined as the distance a value or expression is located from zero on the number line. And we can use compound inequalities to assist us with solving these absolute value inequalities. And what this means is if you're dealing with less than or less than or equal to or greater than or equal to with an absolute value inequality, you can split them into two types of compound inequalities. So let's look at less than or equal to. Well, what this means is your distance, if you're dealing with absolute value, if we look down here, absolute value x is less than or equal to a, that means that expression is within a units from zero on the number line. The distance is within a unit, so it's inside a unit. So that is an and compound inequality. It's within or between those numerical values. So I have the absolute value of x is less than or equal to a, then I split it into this compound inequality where my x is located within a units of zero for it. And that's kind of when we did the absolute value equations. I would put my expression above. So, my x can be within a unit, so it's located here, or my x can be within a units to the left of it, so it's here. So negative a is less than or equal to x, which is less than or equal to a. So if it's a less than inequality, we convert it to an and compound inequality. Now, one way to help you with this is rather than pronouncing it as less than, pronounce it as less than. And that reminds you to convert it to an and compound inequality when dealing with absolute value inequalities. Now, if it's greater than or equal to, that means your distance, so absolute value of x is greater than or equal to a, your distance is beyond or outside that point. It's greater than a units. So that means your x is a units away and it can go greater than that. So it can go to the right. So x is greater than or equal to a. The other way of doing it is, well, if I go to the left and I'm beyond a units, I would be going further to the left. And so that means your x is less than or equal to negative a. And so we can split greater than or greater than or equal to an or compound inequality. And that'll help you with this, just like before, we can do some mispronouncing. We can think of it as great or, and that allows us to know that absolute value inequalities that are using the greater than symbol are or compound inequalities. Now, the part that's tricky for some students is this part right here because your inequality symbol changes. Here it's greater than or equal to, while here it's less than. One way to keep this in mind is that you know that when you divide or multiply by a negative when you're solving an inequality, you flip the inequality symbol. And so since I multiplied a by a negative, this inequality symbol has to flip around. And so that's one way to kind of look at that particular part of the or compound inequality to help you out. So this just introduces what we're going to change each absolute value inequality into. If it's an absolute value is less than or equal to, it's an and compound inequality. If it's greater than or equal to, it's an or compound inequality. So at least get some understanding of this before we move on to the examples.